Okay, then the last problem here, it says a generator in figure 812 has a line voltage of 865 volts, and the resistive loads are equal to 50 ohms. And he says, what's the voltage across each resistor? Now, we can make this work with what we have here as given, but there's an easier way to do this as opposed to these combinations that we have. And the easier way to do that is to determine what the line to neutral voltage is. So ELN square root of 3 times E line to neutral. And so line to neutral divided equals line voltage divided by square root of 3. And that's going to come out to be 500 volts. Okay, so now we know that that's 500 volts, you know, that the resistor's seeing. I've got part A done, right? That's A. And then what is the current in each resistor? Well, if it's seeing 500 volts and it's 50 ohms, then it's going to be 500 divided by 50, or 10 amps that it would see through there. And the total power of the generator would be the total power absorbed by the resistors. So if I look at that, you know, it's 500 volts times 10 amps, and that's going to be 5,000 watts. That's for one resistor. Multiply it by 3, and the total power delivered by the generator to all 3 resistors would be 15 kilowatts. Okay, now there's the heavy lifting with this chapter. That's for the Y configuration. We won't go through all the detail on the delta, but we're going to see that these same relationships that work for Y in terms of voltage, we can also do with delta in terms of current. All right, so, and that also gives us a little hint as to why we might want to connect one over the other.